All right, good morning, sixth graders. It is Tuesday, April 21st. I hope you all had a wonderful weekend. Today we're going to start with Understanding Integers, pages 21 and 22. Okay, so let's take a look at this number line. And we are looking here at 0. So all the numbers to the left of 0 are negative. And it says here, which is greater, -9 or -4? So remember, anything going right is greater than anything going left. So -9 is here, -4 is here. So -4, oops, let me turn this on. -4 is greater than -9 because it is to the right, and I'm going to type this in, because see if I can type this in and be a little bit easier. Okay, so -4 is to the right of -9 on the number line. So it is greater than -9. All right, so now let's take a look at this. Remember, these bars here mean absolute value. And all absolute value means is distance from 0. So absolute value is distance from 0. Okay, so distance, whoops, that's not very good. Distance, I should have typed it, from, whoops, from 0. Okay, and distance is not ever negative. So when we look at this, this meaning distance from 0, these bars, so -9 is 9 spaces or 9 steps from 0. So -9, the absolute value of -9 is 9, and the absolute value of -4, distance from 0, is 4. So which is greater there? Well, the absolute value of -9 is greater than the absolute value of -4 because, let me type this in so that it's easier for you to see. Okay, so, all right, so as I said, absolute value is the distance from 0 on the number line. All right, so distance isn't negative, it's just steps from 0. So -9 is farther from 0 than -4. Oops. So, yeah, I can't make absolute value signs. Hold on. Oops, that will. Okay, so the absolute value, I don't know if there's a, I don't think there is. So let me see here if how I can do this. Hold on. I'm going to pause this. I'm going to lose some of this, but I'll be able to finish it and you can see it together. All right, hold on here. Oh no, it didn't take it away. Good. So the absolute, I thought it would take it away. So the absolute value of -9, okay, those bars, and that's supposed to be a straight bar, is greater, oops, greater oops, is greater than the absolute value of -4. Because -9, the absolute value is 9 steps from 0, and -4, the absolute value is 4 away from 0. All right, let's move on to number 2. All right, number 2 says, a football team tries to move the ball forward as many yards as possible on each play, but sometimes they end up behind where they started. The distances in yards that a team moves on its first 5 plays are 2, -1, 4, 3, and -5. A positive number indicates moving the ball forward, and a negative number indicates moving the ball backward. Okay, I have drawn a number line just to kind of show you so I can illustrate how to figure this out. Or how to visually see it. I know that you can figure it out without the number line. All right, so let's plot these points. We've got 2, and we've got -1, and we've got 4, and 3, and -5. Okay, so those are the 5 plays. So a positive number indicates moving the ball forward, so they were going toward their goal this way. Negative number is when they got kind of pushed back. So which number in the list is greatest? Well, we know that positive numbers are always bigger than negative numbers. So we know that going this way, even though this is a -5, and you think 5 is bigger than 4, but because this is negative, the greatest number there is 4. Okay? So, what is a better question to ask to find out which play went the farthest from where the team started? Okay, so if the team is starting at 0, they actually went farthest when they went this way, okay? The greatest number that's marked is a 4, but remember, absolute value is just distance, and the distance from 0, this is 5 steps from 0. So actually, really what they probably should have asked here is, whoops, oh, I didn't mean to do that. I was trying to change it to text. So probably a better answer or question that they could have asked is, which number has the greatest absolute value? If they're trying to find which play went the farthest from where the team started at 0, then -5 would be the answer there, because that absolute value is distance. So this was 5 steps from 0. Okay. All right, now it says the coach considers any play that moves the team more than 4 yards from where they started a big play. Which plays are big plays? All right, so the play that moved, we just talked about it. Let me draw this text box. And we just talked about it. The play that moved the team -5 yards is a big play, because that was actually 5 places from 0, or 5 steps from 0, 5 yards from 0 is what it was. 5 yards from 0, and that's a bigger distance than 4 yards from 0. All right, good. All right, now number 3. When does it make sense to compare the absolute values of numbers rather than the numbers themselves? Well, let's take a look. If a number or if a problem deals with distance, then it makes more sense to compare, compare absolute values because they have to do with distance. If a problem deals with value, then it makes sense to compare the numbers, and we know that positives are always greater than negatives. All right, I hope that helped you. Let's move on to the next page. All right, this page has to do with the coordinate plane. Okay, you know that there are 4 quadrants, and I hope you remember from Mr. Gregory teaching you, let me go over here, that, hold on, oh my, let's see here, there we go. This is quadrant 1. This is Roman numeral 1 for quadrant 1. This is quadrant 2. It's a Roman numeral for 2. This is quadrant 3. And then we write the Roman numeral for 4. It's like this, because the way this is V is 5, and so if the 1 is in front of 5, you're taking 1 away, so that's 4. So 6 would be V1, because then you're adding 1, okay? All right, so now let's take a look at our questions. For problems 1 to 6, plot and label each point in the coordinate plane. Name the quadrant or axis where the point is located. All right, so let's take a look at that. All right, I'm going to change colors here so that I can mark these and you can tell where they are. -3, -2. So remember, we always start at 0. And then we go on the x-axis first, so across here first. So we go over here, 1, 2, 3, and then down 1, 2, and here is -3, 2, and we're going to label that as A. All right, now let's go to B. 4, -4, go back and start at 0. It's a +4, so we go this way. And then it's a -4, so we go down. 1, 2, 3, 1, 2, 3, 4. So this is B. And C is 2, 3, 1, 2, and then we go up. 1, 2, 3. Okay? And that is C. I think you guys have the idea of that. I'm going to let you do the last 3 on your own. But now what they've asked is for you to tell what quadrant they're in. And actually, guys, on your paper, you might even label the quadrants up here so that you have room to actually label the points, because it's asking us to label the points. So B would be, let's see, 4, -4. So you would actually go like this, 4, comma, -4, okay? When they say plot and label, that's what they want you to do. Plot it means to put the point there, and then label it, B, and then the points. All right, so let's look at C. C was 2, 3. Okay, and then A was -3, -2. And I should have put a -3, comma, -2. All right? All right, I'll let you plot and label the remaining ones. And then we just have to look here, -3, -2. This is quadrant 3. So we go up here and we can write quadrant 3. Oh boy. 1, 2, 3. Okay. And then B, you could just have to go and look, and it's in quadrant 4. I'm going to put Q equals quadrant 4. Okay. Actually, I meant to, I'm so used to writing regular, I don't know whether it matters to Mr. Gregory, but we're going to put it down like that. And then, of course, quadrant, this one, C, is in quadrant 1. Okay? All right. So you go ahead and do the remaining 3, and we'll move on to the next one. It says, if your point E above is reflected across the x-axis, what would be the coordinates of the reflection? Okay, well, let's look at E. It looks like we'll be doing another one together. So 3, start at 0, 1, 2, 3, and then -3, 1, 2, 3 is right here. All right, a reflection over the x-axis, this is the x-axis, it would be like you folded the paper and the same distance this is from the y and x-axis is going to be the same up here. So let's take a look. It is 1, 2, 3 from the y-axis. So 1, 2, 3 is going to be right here. And then from the x-axis, the distance is 1, 2, 3. So it's going to be 1, 2, 3 here. So 3 distance from y and 1, 2, 3 x. This is the reflection. I'll put it in purple, and that will be E. Okay, that is the reflection of, wait a minute, this is E, sorry guys, this is the E, this point here, the purple point, 3, -3 is E. Okay, this up here is not E, it's the reflection of E, the reflection. We reflected it over the x-axis. Of E, all right? So we just reflected the same distance over the x-axis. All right, so let's go ahead and make an explanation for that. All right, so we had said, oops, oh dear, here we go, that point E is 3 units, whoops, is, okay, why isn't that working? Is 3 units to the right of the y-axis and 3 units below the x-axis. Okay, so you see that point E, 3, -3, is 3 units away from the y-axis and 3 units down or below the x-axis. So to do its reflection is also 3 units, units to the right of the y-axis Oops. And it is 3 units above the x-axis. So that is 0.33. So the reflection is 3 units to the right of the y-axis, but now we're going to go up to 3 instead of below 3. Okay? All righty, let's move on. All right, let's look at number 8. It says, imagine that one of the points given in problems 1 to 6 has been reflected. The reflection is in quadrant 2. What are the possible coordinates of the reflected point? All right, so mine is not showing anymore because I had to move it. Maybe I can put it back up here. So we had A at -3, -2. Okay, -3, -2. We had A at -3, -2. This was point A. Okay, A. All right, and then we had C, 2, 3. 2, 3 was C. Okay, so this was C. All right, so it's asking you, it's telling you that the reflection ended up in quadrant 2. Okay, that's where it's telling you it ended up. So if we reflect A over the x-axis, we have to find what points that would be, but that would be in quadrant 2. Or if we reflected C over the y-axis, that would be in quadrant 2. So I'm going to do one of them, and then I'd like you to do the other one. So let's look at A, okay? Point A is at -3, 2. So to reflect it, we have to go -3, but up 2. Okay, so it would be here. This is the reflection of A. I'm just going to put R for reflection of A, so you can see that. Okay, so when we reflect across, we go the same distance from Y, and then, but we go up instead of down. So this is going to be the reflection right here, and that is at point. So if we reflect, hold on, sorry. If we reflect point A, if we reflect, whoops, point A, the reflection will be in quadrant 2, and that's what our directions are. Whoops, I'm in the wrong spot, guys, sorry. Oh boy. Okay, if we reflect point A, the reflection will be in quadrant 2. Okay, and the point will be -3, but +2. Okay, that's the reflection. All right. So what I'd like you to do is C. So here's the original point. C is 2, 3, but now you're going to reflect it over the y-axis. So you work on that and do that the same way we just did point A. All right, let's move on. Okay, guys, let's take a look at number 9. All right, I cannot show you my grid because I still haven't figured out how to, I can't go up and down once I put this text box in. But you have yours in front of you, and we already plotted B, and B is at 4, -4. So look at yours, and you can see that it's 4, -4. Now, if we reflect that over the y-axis, it'll be -4, -4. So if we reflect point B over the y-axis, our answer is at point, or I'm sorry, is at, let's see, -4, -4, -4. Okay? All right, then it's telling us, it says, Bradley says that if point B is reflected across the y-axis, and its reflection is then reflected across the x-axis, the result is point D. So is Bradley correct? So that's what we're finding. So you look at your coordinate, you see where your grid, and you can see point B is at 4, -4. And then when we reflect it across the y-axis, then we're going to get -4, -4. And then it says to reflect that point over the x-axis. And when we reflect that point over the x, or let me see, let me be specific. When we reflect -4, -4 over the x-axis, we go to -4, and then up 4, up to +4, okay, across to -4 and up 4. All right, so when we do that, now let's look at our grid and see if that's where point D is. So we should have -4, 4, but point D is -2, 4. So we have to decide if Bradley is correct. Bradley is incorrect because we just found out why. Okay? All right, that is it for today. That was a long lesson for only 2 pages, but I hope you did well, and post your work or send us even just a dojo message saying that you're working on it and watching the videos, and that will be great. All right, have a great day. Bye.